All right, hi guys. This is day 10. We are closing in on the end of exponents and the end of NTI and the end of the school year, which is crazy. You guys have been doing great so far. So we've got about 4 more lessons in this section, and then we're going to be wrapping up for the year. So let's go ahead and dive into this. Where we were just in was 6.1, exponential growth functions, all that stuff we're going to keep in the same direction. So I'm going to pull up our equation to remind us where we've been. We know that A represents that initial amount, so your starting value, your initial amount. We know that B is the growth factor or decay, and we know that X is time. We also know that Y is that final value. We know that we can break B down into 1 plus R if it's growth. We know that B can be 1 minus R if it's decay. And we know that R is going to be in a decimal, okay? So remember, either move the decimal 2 to the left. So if it's like this, 2.5. Oh, that's from the problem. Let's do a different one. Let's do 2.9. Move it over 2 to the left, put in a placeholder. Or you would do 2.9 divided by 100, and that's going to give you your decimal every time. So let's go ahead and look at our equation. The reason that this example is in 6.2 and the reason that it's different than 6.1 is because before we were given something in an expression of time, and then we were told to solve for that same expression of time. Now what's happening is we're given our rate value in terms of year, and then we're asked to find the monthly growth rate. So we have to convert from years to months. So let's write our equation as we normally would, though, using our initial value and our growth factor. So the initial population was 8,000. So that's my A. The population is increasing, so that means we are going to add at 2.5% per year. So you can do 2.5%. divided by 100. Remember, you're never going to type that percent into the calculator because your calculator doesn't have a percent sign and it doesn't need one. And you're going to get 0.025. You could also move that decimal 2 to the left, and I get 0.025. And then I have to my exponent x that represents time. So this is a great model. This is using the yearly growth rate. I could calculate the population in 10 years, 5 years, whatever it is. But I want to know what the monthly growth rate is. So I need to think about how many months are in a year. If I look at this growth rate for 3 months or 3 years, how many months did that cover? If I look at it for 4 years, how many months did that cover? Basically, I want to know using my year, what operation do I have to do to figure out the month for each time? So, sorry, that was a really bad way of wording it. So for every year, how many months is that? So basically what I want to do is I want to take my time and I want to multiply it by 12. So for every year, whether that's 4 years, 4 times 12 will tell you how many months you covered. 5 years, 5 times 12 will tell you how many months. But the problem is that we can't just go and add a multiple of 12 into the equation because then that changes things. I can't just look at this problem and be like, yeah, you know what, I'm going to also add 5 at the end too. It disrupts the equation. So in order to multiply by 12, we have to make it 12 over 12 because 12 over 12 is just 1. So it's the same way like when you get a common denominator in fractions, whatever you do to the denominator, you have to do to the numerator because that just means you're multiplying by 1, and that's fine. You're totally allowed to do that. So I'm going to clean this up, my equation. So I've got y equals 8,000. I'm going to combine this. 1 plus 0.025 is 1.025. And then I've got 12 x over 12. So now what I want to do is I want to break this down and I want to find the monthly growth rate. Okay, so this is the yearly growth rate and I want to convert that to the monthly growth rate. So using laws of exponents, I know that when I've got an exponent that looks like this and the exponents are separated by a parentheses, that you just multiply those together. So a equals x a times b. And so I'm going to do the opposite here. Since all of the exponent is on the outside and I want to split it between outside the parenthesis and inside the parenthesis, I'm going to take the denominator and I'm going to move it to, I'm going to take the denominator and move it to the inside of the parentheses. So it's going to look something like this. And I know it's a little wonky, but I'll explain it kind of more cohesively at the end. So I'm going to move the denominator into this exponent and leave the 12x on that side. So now my yearly growth rate is going to be to the exponent of 1/12 because 1/12 of a year is the month. So all I need to do is just figure out this piece of my calculator. So again, if that was kind of hard to follow, the good news is the problem's over. I just want to know that right there. So I'm going to go to my calculator and I'm going to figure out what that is. And then that inside parentheses is going to be my monthly growth rate. So we'll go here. Look at my calculator is finally horizontal. I didn't know that it did that, and maybe it did it all along and I was just stupid. I didn't know, but I'm really excited. So 1 plus 0.025. Oops, 25. Yikes, I'm struggling. To the alpha y equals, this is how you get your fraction, 1/12. Remember, this calculator is called Calculate 84. I'm positive that it is a iPhone app. I am not that sure if it's an Android app. I think there's something comparable. Again, the TI 84 software is on your Chromebooks. If you have a school Chromebook in the apps section, it's also free to download for anyone if you're using a personal device. Bam, hit enter, and we'll round that out to 1.00206. Okay, so remember, this was like our last example, I think, or our second to last example from 6.1. This is B right here. I don't want to know B, I want to know the growth rate. I just want to know the R value. So to figure out the R value, if B is 1 plus R, and that's this number right here, then all I got to do is subtract 1 from both sides, and R is 0.00206. And that's my monthly growth value. So when you try this on your own, it's easy to think of it if you think of it like this. I'm getting you guys ready to do your target. So if you've got y equals a times 1 plus or minus r to the 1 over n to the n times t. Okay? And so this n value right here is going to be whatever the division of the year is. So if it is monthly, you know that there's 12 months in a year. If it's semi-annually, you know that's 2. If it is weekly, you know there's 52 weeks in a year. If it's quarterly, that happens 4 times a year. Yeah. So I think those are the most common ones that you guys are going to run into. And so your answer is, again, just this guy in the middle. Okay? So in my instance, it was month, so everything was 12 because I'm dividing the year by 12. But if it's any of these other ones, then you'll divide the year by 2 if it's semi-annually, 52 if it's weekly, quarterly, and so on. So yeah, I am going to go ahead and wrap this up now. Sorry, I got distracted by an email. All right, I love you guys. I miss you very much. Email me with questions, comments, concerns, remind, text, Google Classroom questions, anything you guys need. All right, love you guys. Bye.